Okay, in this video, we will prove example 4 and example 5 on the handout. This is page number 40. Page 40, and we are doing unit 2B, which is lines parallel and all angle relations and proof stuff. Okay, next one. Given information, angle 1, angle 4 are congruent to each other, and angle 3 and angle 4 are supplementary. And now let's prove two lines are parallel. So let's start with all given information. What is given information? Here, this and that, right? So where is it? Here and on here, right? So let's fill out the blanks. So first one given, and let's go with the third one. Angle 3 and angle 4 are supplementary. SUPPL, that's enough. Supplementary angles, okay. Now let's see. Measure of the angle 1 is same as measure of the angle 4 on the second step. It is directly from number 1. How can I say measure of the angle 1 is same as measure of angle 4 from that given information? Given information, first step is geometric notation. Second one is algebra notation because of M, an equal sign. How do we go back and forth between geometry and algebra? What is the key thing? Definition, okay? I need to use definition as a reasoning. What definition are we talking about here? Definition of congruent. What is the part? Is it segment or angle? Angles, that's right. So we're using definition of congruent angles to go back and forth between two different words, algebra and geometry, okay? So memorize that. Key is the definition, okay? And then find out the details from the statements. Next one, number 4 is the conclusion from very close above one. Angle 3 and angle 4 are supplementary, so I can say measure of angle 3 and measure of angle 4 is 180 degrees. What's the reasoning? That's right. Again, definition of what? Supplementary angles. That's right. So it is grouped together, and this is kind of supporting details, okay? So we need to use the supplementary angles. Definition of supplementary angles, that gives us the next step. And now I need to look at that, and then where do I get 5? So you need to think about all above information to make a conclusion, okay? Where do I get this? Is it similar like above? Yes, it is, but except to something, right? What is replaced? Instead of using measure of the angle 4, I'm using measure of the angle 1, right? So I'm combining second one and the fourth one to create fifth one. Make sense? So what's the reasoning? What happened here? That's right, we substituted, right? Substitution. Property of, I see equation, so we will say equality. Now, the next one is blank, so I need to think about given reasons. The reason says vertical angles are congruent. Vertical angles congruence theorem. So which two are vertical angles? To say measure of the angle 2 and measure of the angle 1 in the next step. We have a lot of vertical angles here, right? But I need this one. So I need to go with this, okay? So what angle do I need to use? Angle 2 and angle 3. Angle 2 and angle 3. So I can connect this. So I can say, all right, here angle 2, angle 3. So let's have some little bridge between them, okay? So by using vertical angles congruence theorem, I can say measure of the angle 2 is same as measure of the angle 3. Instead of using congruence statement, I use the equal sign between the measures, the numbers, so I can use the next step quickly. What would be the reasoning to state this one from 5th to 7th? I replace, right? So this will be, again, substitution method. Substitution. Substitution, something's wrong, right? Substitution, substitution property, not method. Property of equality. And now angle 2 and angle 1, they are supplementary. So what's the relation between angle 1 and angle 2? What's the name of this? Angle 1, I'm sorry, angle 1, I drew the angle in the wrong place. Angle 1 and angle 2, they are together, same side and together inside, right? So that is same side interior angles. They are supplementary, right? So I need to say two lines are parallel, so I have to start with the converse. Converse of what? Let's read the name. Same side interior angles. Are they congruent or not? They are not congruent, so don't write congruent here, okay? Same side interior angles theorem. That's it. So you must know we are using converse to prove the backwards of the process, okay? Two lines are parallel. You must have converse on your reasoning. Okay, next one. Question number 5, example 5. A carpenter is creating this pattern and show that two pieces are parallel. To do that, I must use angle 1 and 2. Angle 1 and angle 2, what's the name of these two angles? Same side? Interior angles, right? So by using the same kind of thing above, and I need to use that. So my conclusion will be by using converse of same side interior angles theorem, I can say two lines are parallel. A and B are parallel. That will be my conclusion. So I need to show all the numbers, right? To show that, I need to say those numbers are making 180 degrees. So let's calculate. So let's plug 15. What's the number? 15 times 8 plus 20. And next step, let's plug the number and then add them. That's 30 and 40, right? Is it 160? I'm sorry, 140? Okay, so what do we see? Measure of the angle 1 and measure of the angle 2 together makes 100 degrees, right? Wow, what does that mean? That forms two kinds of angles on a parallel lines with the transversal, right? We got two kinds, one acute, one obtuse, and forming same angles or together 180 degrees. That means the lines are parallel to each other. So we are using converse of the same side interior angles theorem to prove two lines are parallel.